Thank you, everybody. Thank you all for coming tonight. Tonight's speaker, Joe Decuir, KF7 BMD, is an amateur extra and a volunteer examiner. He's been licensed since 2008. He's taught ham radio classes and contributed to medical electronics, video games, personal computers, dial-up modems, networking technology, operating systems, USB, and of course, the thing we're all here to hear about tonight, Bluetooth. Since 2016, he has been teaching electronics at the University of Washington Bothell campus, and as I said before, this guy has a Wikipedia entry.
I want to talk about two things. I want to talk about the lowest layers in the Bluetooth radio, because you're all radio heads by definition, right? So I figure you want to know about what goes over the air and how you manage those bits, and that's it. I will, for perspective, mention that Bluetooth is an ecosystem that starts with layer 1 and goes all the way up to layer 7, which is the applications layer. And the issues that come up from that are what causes some of you to run into some difficulties, because you'd like it to do things that the manufacturers didn't enable, because if you cross all the radios and all the applications, you get tremendously complicated stuff. So they don't build everything in any given product, even if it can say Bluetooth on the side of it. In fact, there's a lawyer unemployment clause in the Bluetooth membership agreement. There are at least 30,000 member companies in the Bluetooth special interest group. And it turns out that the headquarters is on the Kirkland waterfront. And a person that this company foolishly laid off recently, Toby Nixon, was the chairman of the Bluetooth SIG special interest group. He hit 30 years in January or February, and they laid him off in March. He's still active. He's on the Kirkland City Council. He's a fellow cert, so I still see him. But that was Microsoft's connection in this. Now, the Bluetooth Special Interest Group, in their membership agreement, they require all members to agree that any intellectual property that they have that applies to Bluetooth specs is shared with all other members of the Bluetooth SIG if they prove compatibility, which they call qualification. So some random person could become a member of the Bluetooth SIG, sign the membership agreement, you design something that uses Bluetooth in it. There's intellectual property all over the place in Bluetooth technology. But if your device is qualified and you pay probably 4 digits the last time I looked, fixed fee as your qualification fee, you're covered and you bore the lawyers, which is a great thing, right? So that's how the whole thing works. And so it's not like the IEEE, where organizations can still have separate patent pools and they can perhaps, get together to extract money out of various people. Bluetooth SIG drives interoperability in return for, for compatibility, so that if a user sees a product that says Bluetooth on the side of it, for the things that it claims to be compatible with, it works. Fair enough? Right. So I'm going to talk about how the radios work, and then I have collected a lot of questions, mostly from Mr. Hopper, and I'm trying to answer some of those questions. And I'll stick around here until you guys are bored, and I'm going to go home and have dinner. Fair enough? Okay, so where is the next? Okay, it's short range wireless communications. I'm going to talk about the physical and MAC layers. Everybody here knows what MAC means, right? It's not Macintosh as in Apple. It's media access control, layer 2. What's it good for? what to be worried about, where to learn more, contacts and disclaimers. So how does it work? Radio. How many of you know why the ISM band is unlicensed? That's incorrect. It's not that it's unusable.
It's hard to use.
Water vapor absorbs it. 2850, right? So all the cell phone companies will not license that band because they can't count on it, right? So 2400 to 2483 wavelength is about 12 centimeters. The maximum transmit power, which is very rarely used, is 20 dB. Common is 4 dBm. The minimum is 1 milliwatt, 0 dBm, right? And the modulation is mostly frequency shift key or phase shift key. I'll talk a little bit more about that later, but that's what it is. In fact, as I'll get to later, they considered extending in various ways and decided not to go that way. But it does adaptive frequency hopping, which I will try to explain, because that's a very crucial feature. So this is a crowded band because it's unlicensed worldwide. And the crowd includes Bluetooth radios themselves, which are hopping all over the place. Older IEEE 802.11/Wi-Fi radios, especially in channels 1, 6, and 11. And Zigbee 802.15.4 radios, which the older versions didn't frequency hop, so that they just camp out somewhere if they're working at all, in which case everybody has to get used to them. The spectrum around ISM is very crowded. People have been licensing spectrum up to 2400 and above 2500. So modern versions of Bluetooth have interoperability to make sure that a given device isn't trying to transmit on Bluetooth and listen on an adjacent band at the same time. Otherwise, you'll desense the other radio. Even if your output frequencies filters are pretty tight, you know, it's not going to be enough if they're right next door, and vice versa. Make sense? So obviously, microwave ovens, that's how we cook our food, right? It works. Water vapor absorbs it and gets hot, and it's a serious range limiter for public use. So the Bluetooth pieces, I talked about layers. What we're going to talk about here is mostly the link layer and the physical layer. A common break in the system, especially in the oldest systems, people would build a chip and there would be a host controller interface like USB or a handful of pins. So they'd sell a chip that, you know, this connects to the radio and power, and this connects to whatever else is controlling the thing. Could be anything. And above it, logical link control, adaptation, attribute protocol, generic attribute profile, and generic access profile, higher and higher layers that stitch together all the things that are going on, and the applications, which are the profiles and services, right? So let's pick an example. I've got in my shirt here a wrong pocket. I took it off my head and I think I put it back in my pocket here. Here we go. Yeah, right. I used to work for a company called Cambridge Silicon Radio. They were the world's largest maker of Bluetooth chips on the planet at the time. And so this headset here has the classic Bluetooth radio and Bluetooth streaming audio, SCO, and it supports 2 applications. First application is what's called hands-free profile. So it has a microphone sends the data by Bluetooth to something else, like this guy. And it takes the audio from this guy and plays it back to me, right? Simple. And the other application it supports is streaming 2-channel music. It has a slightly higher quality audio path. And it, of course, is going to mix it so I only get mono in my ear, but I've got stereo headsets. Stereo headsets will get both channels and all that. So those are the two profiles and services that are in this thing on top of this radio. Does that help? I'm trying to make it tangible because many of you have these things. And the reason you might have these things is because in the last 25 years, please don't drive with your head, your phone in your ear. That's called distracted driving. That's a several $100 fine in this state and many other states and many other countries. So don't do that. And that application was driven by that administrative need. Make sense? Okay, so far so good. So core version radio summary. Okay, going back to 1998, core version 1, basic rate. Gaussian frequency shift key, 1 megasymbol per second to 1 megabit per second. Half duplex. I'll talk more about how it manages frequencies later. In second core version, early 2000s, extended data rates. So they first of all did frequency phase shift key, 4 phases, 2 bits per symbol, and they did 8-phase PSK for 3 bits per symbol. So you get 2 and 3 megabits per second. So far, so good. That's the early evolution. We did it ourselves. We went out and back again here, and we said, hey, what about fast stuff? And so we designed a version which had an adaptation layer to 802.11n. So we're looking at several hundred megabits per second as an alternate Mac and Phi. Now, what happened was most of the market decided that they didn't care, so they ripped it all out eventually. What we had also done, my company prototyped a 480 megabit per second ultra wideband radio. And we were working on wireless USB for USB 2.0, 480 megabits per second. Does someone want attention? Okay. Okay, so we actually, in the original draft of 3.0, we had 2 alternate Mac and Phis, one based on 802.11 and one based on ECMA 386 multiband OFDM, which is going to just blaze. If we had approved that, I think at this time in history, Bluetooth over OFDM would own short-range video. But the board scuttled it, so and the rest of the market decided they didn't care. So in later versions, that's been ripped out of the document. We then went in the other direction. We started saying, well, okay, this is a relatively low power radio. How can we make it even lower power? And the fundamental insight is that you can get to really low energy if you just redesign the system for very low duty cycle. I will be explaining that in the slides today. And the carrier is slightly different. It's slightly wider, FSK. It's a 2 megahertz bandwidth rather than 1 megahertz bandwidth. That gives it a little bit more range, maybe 20 meters instead of 10 meters inside a building. Okay, but it's the same rate, megabit per second. Okay, then after I left, they did version 5. And so they went in 2 different directions. One was they went a little faster at short range. So they changed frequency of 2 megasymbols per second, but still just 2 phases to give them 2 megabits per second. And they also went in the other direction. Let's say, how far can we go? So they took the LE radio and they said, okay, let's, error control it. So there, for a net rate of 500, 1/2 to 1/8, but they get a whole lot more range. I'm not including the ranges here, but I've been involved in tests where our range was 1 kilometer.
I did a third of a mile and I got tired of walking. Seriously,
Right.
That's what happened.
Right.
That was on the 8, not the 2.
Yeah. Right. Well, my cardiologists are happy if I do a lot of walking every day. So I probably would have walked until it gave up on me, or I ran out of a straight shot.
This was not a straight shot. This was some serious things.
Yeah. When I've tried to do range testing and stuff, I've used Marymore.
No.
Because there's like soccer fields and stuff. Right. So 3 is deprecated. The market doesn't care. We ripped it out of the version 5. Any questions on this?
Yeah. There's 2 actual. There's low energy and there's VR or EVR.
Right.
And they're almost, you should look at them as being separate in a way.
They are separate. As
They
a matter
are,
of fact, you
but
can
they're
build
the
a
same
device that's
technology.
only LE compatible, and you can build a device that's only BR EDR compatible, and they won't talk to each other.
And the other thing I guess they say is that there's hit devices on VR.
Right. And there's hit on BR and there's hit on LE.
I made the mistake of buying a keyboard thinking that it was getting LE and VR.
Really?
Yeah.
Okay.
Because the chips for VR are so, the Chinese chips are so cheap. They're $7 for a keyboard.
Why am I not surprised? Okay. All right. Okay. So let's get in a little bit more detail. So symbol rate in all but one case is 1 megasymbol per second. Now, can I assume that everybody here has some fundamental understandings of digital modes? And there's the symbol rate and how many different symbols per symbol. And if you've got FSK, it's one frequency or another frequency, for example. And so the symbol rate is the same as the data rate. Now, I used to work, a long time ago, I read an article about what was going to become the internet. It was an article in IEEE Spectrum about the Minitel in 1978. And my head exploded. I'm at Atari working on their first personal computer. And I realized that ROM-based cartridges is not going to scale. Computer-assisted communication is going to scale. And I recognized that the Minitel system was basically a French national prototype of the internet. So after we finished working on the personal computer at Atari, I left to do my first startup, which wound up selling hundreds of millions of modems, until we went out of business. Microsoft hired me in 1992, and I was one of several people whispering in Bill's ear about how important the internet was going to become. And that worked. In 1995, I went to the company meeting in the Tacoma Dome, and Bill gives us a half-hour commercial about how important the internet is going to be. And then at the end, he said, I have something else to tell you about. And so there's a picture of Bill. He's laying on his back on a carpet in a living room. He's holding up his 6-month-old daughter, and she's throwing up on him. We needed the comic relief. But so I worked on modems for a long time, and I actually went to all the meetings in Geneva where we were standardizing all these V-series modems. And I was still going to Geneva in the 90s representing Microsoft. And I mostly worked on the modems until we finished with 56K. And as a side effect, I was working on the G series standards for audio video conferencing on the internet, which is the basis of Zoom and Teams and all those things. I'm one of the perps. One of the perps. Let's get back to this, okay? Symbol rates, data rates. So if we have forward error correction, 2 to 1, so we cut our data rate in half. And of course, we always do CRC. Do everybody know what CRCs are? Right? And we're cutting data rates down. And so we can get, unity range, double range, 4 times range. And as you said, you ran out of, your feet must have gotten sore or something. Okay. Right. Now, it's mandatory that all Bluetooth machines that are LE at all support this, and all of these are optional. But like I said before, Bluetooth gives you intellectual property if you prove compatibility. So Bluetooth, for every implementation spec, Bluetooth will have at least one spec that you must pass to qualify. And so they'll have a set of tests that cover these if you claim on your check sheet that you do those things. Okay. If you're inside a building, lots of walls and whatnot, range is nominally 20 meters. But if you're outside, again, you can get sore feet. Any questions about that? Okay, it's going to get more interesting now. Bluetooth was designed from scratch to survive in crowded and dynamic spectrum. So BR and EDR occupy 1 megahertz at any given instant over 80 channels. So the master device instructs the other devices on how to do, they exchange when they do bonding and pairing. One of the things that they come out of that is a pseudorandom number seed, and they will run that pseudorandom number seed. So each device, as they jump from one frequency to the next, can predict where it's going to jump to, which of 80 frequencies. So let's suppose they're at a frequency and it works. So they're exchanging data. They're happy, right? And then they both jump at the same time to some other place. Master will speak first, and then the responding device will answer. And if it doesn't work, if they're accumulating errors on either side, they'll stay there for the time allocated, and they'll record the fact that this sucked. And the next time they jump somewhere, they'll exchange messages to say, by the way, that last one sucked. Let's stay away from it for 500 milliseconds. So if you put a spectrum analyzer on the ISM band and you let Bluetooth things by themselves talk and they'll dance all over the spectrum. And then if you turn on a Wi-Fi channel, suddenly the Bluetooth devices you'll see the spectrum from the Wi-Fi rise. And then the Bluetooth devices will start avoiding the Wi-Fi stuff because they'll discover that it sucks now. And so they'll jump around it until it goes away, and then they'll jump back. Make sense? That's what they do. Okay. Now, the difference here is that in Bluetooth LE, we increased the width of the FSK to get more range, and we got half the number of channels to 40 instead of 80, but it still otherwise acts in the same way. So far, so good? Okay, so they hop together. If it works, they send it, they talk. If it doesn't work, they log that fact, and then the next time they get to some place where they can talk, they say, oh, by the way, stay away from that last one for a while. That's what they do. So this is the LE versus BR-EDR. So it's wider spacing, so there's only 40 channels from channel 0 to 39. And they arrange it so that here's Wi-Fi channel 1, and here's Wi-Fi channel 6, and here's Wi-Fi channel 11. And so having evolved after the popularity of Wi-Fi, they said, okay, let's choose this frequency and this frequency and this frequency as the advertising channels. Now, regular BREDR, when they're trying to find each other, they broadcast and listen on 32 different channels. You ever lost a kid in Disneyland? You know, if you're lucky, the kid holds still and you can run all over the place until you find the kid. But if you're not, the kid is running too. And they may leave a place where you come up to and you keep, you understand how hopeless it is, right? Right. So with that in mind, when they were reinventing Bluetooth, they said, okay, here's only 3 frequencies. So the device that wants attention sends out a message here and here and here. So the thing that's listening is only listening on those 3 channels. It might only be listening on one of them. And if it catches it, then they respond and they can proceed. So it takes a lot less time on 3 channels than on 32 channels. That should make intuitive sense to you radio heads, yeah? Okay, so how's it work? So peripheral that wants attention says, I'm going to say, I want some attention, I want some attention, and I'm on a different frequency, and lo and behold, the central is listening on this frequency, so it sees this message, says, hey! And then they start corresponding. And these times, if you'll notice, they're pretty short. Devices can advertise, anybody want my attention? An example of an application. So I was in this meeting a long time ago, and we were getting a presentation by NTT, which is sort of the Japanese equivalent of AT&T. And they do a lot of advertising in Japan, and they built a little device that sticks on the walls in Shinjuku Station, which is the world's largest shopping center, as well as being a train station. And, you know, if you've got a phone and you're walking around outside in range of GPS, you pick up the GPS signals, you know where you are. If you're underground, you're SOL. But they built an array of little things that you stick on the wall, and they're programmed to every half a second put out a simple message. Here's where you are. Of course, they have to program them because they're in a lot of different places, but they program them out, they lay them all out underground. So suitably equipped phones walk around and they know where they are, which means if you're walking past somebody with this special or this special or this special, your phone will start chirping at you with, oh, come in here for some sushi, yada, yada, yada. Whatever it is that they do, they monetize this. And it can run off of scavenged power. You know, as long as they turn on the lights, the little thing gets enough energy from the lights to keep working, no batteries. So they can broadcast promiscuously like the application I just described. They can transmit signed data to a previously bonded device. Signing, meaning you all understand security by now. Sign means that the receiver believes they know where it came from. Advertise their presence to a device wanting to connect, right? You do something to the device and it starts putting out messages. The other device listens to it and do you want to connect to me? Yes, okay. Bond, pair. Reconnect asynchronously due to a local event that causes some interruption, right? Different reasons to advertise. So once they've formed a connection, then they can switch over to these blue channels. the 37 other channels, and they'll hop amongst those to finish exchanging the data, however long it is. And it can be not very long. Let's suppose I have a temperature sensor on the wall, and it just wants to deliver 16 bits of temperature. And could even be BCD encoded or ASCII encoded, you don't care. But it isn't very much. So it's low energy, not because it's low power when it's running. It's low energy because the duty cycle can become tiny. So let's suppose we're tracking time here in microseconds, and I can advertise, and I can get a connect request, an empty packet for punctuation. I say, here's what I want to talk to, punctuation, I'm done. And attribute protocol handle value indication means maybe it said an attribute protocol handle is saying, here's the kind of data that I'm broadcasting. And by the way, here's the value that's associated with that. So it doesn't take very long at a megabit or less per second. You send it an empty packet for acknowledgement. You say, I'm all done. And another one for punctuation. And basically the whole thing takes 3 milliseconds start to finish. If I want to know the temperature every second, well, there is 60,000 milliseconds in a minute. So my duty cycle is now 3 over 60,000. It's 1 out of 20,000 duty cycle. So if I've got stuff like this going on, my net power consumption is tiny. And if your data rate's lower, it's even lower. So how low can the energy get? Okay, so let's suppose it's a 3 millisecond per minimum transaction. Let's suppose I get a 45 microjoule. 45 microjoule, if it's a 1.5 volt battery, and this stuff runs on less than this. The chip in here, the analog runs at 1.5 volts, and the digital runs at 850 millivolts. Right? Let's suppose it takes 10 milliamps when it's on, but it's only on for a tiny fraction of a second. So I draw 45 microjoules every time it's on. So if I buy an off-the-shelf battery, it's 1.55 volts, 180 milliampere hours, cost $2 back in the day when I wrote this. And so if you divide that all out, it says I can handle 21.6 million transactions, which means it's going to last. If communications was the only thing that I had to do, it'd last 40 years. Well, the battery's actually not good for that long.
Self-discharge is worse.
Self-discharge, and there's other things usually going on in the device, like there's a microprocessor, there's the display, there's the sensor itself. So let's suppose the rest of the device together eats up 40 milliamps when it's on, right? Which means it might last 10 years, but 10 years is plausible for the life of one of those coin cells, right? And in fact, you can run on scavenged power like ambient light, etc. Make sense? Yes, sir.
40 years for a mercury cell.
Right. For good reason. So, okay. Anyway, so what's it good for? There's different kinds of applications, like wearable, like my smartwatch here. What?
Of course, oh yeah, I agree.
Yeah.
Like your sensor. Yep.
Right. Trying to keep them happy, right? It gets really excited when you hit 10,000 steps. Right? Internet of Things stuff, connect to the cloud, discover other radios. Okay. So classic, what we call classic these days, is Bluetooth basic rate and extended data rate. And the big uses, as I was describing, streaming audio, killer app, hands-free stuff required by law, And A2DP is the name of the protocol for listening to stereo. Newer applications, medical devices. So IEEE standardized something called 11073, which standardizes several dozen different medical sensors. It gives you standard descriptions of what all these things are. And then both the USB the USB implementers form basically wrapped them for USB delivered medical data. And the Bluetooth SIG wrapped them over BR EDR for medical connections. So you can go buy off-the-shelf USB connected, let's say, pulse oximeters, all kinds of stuff. It's just off the shelf and it just works, right? So that's examples of what they're good for. Low energy, it's connecting things that especially are going to be battery powered or low powered. So watches, right? I have to charge this thing up 2 or 3 times a week. The remote display. So nowadays, this watch is connected to this, and an announcement comes in here, and it pops up on my watch all the time. Mostly I ignore it, especially if I'm driving, but it connects, right? Tags. You can go to Best Buy and you can buy these little tags, and you know, if you lose things, you put one of those tags in your wallet, and you put the other one on your key ring, let's say. So if you lose one of them, they're Bluetooth connected, and you can use one of them to find the other one. Make sense? As all of us get a little slower as we get older. My father, who died 3 weeks ago, he used to say that there's 2 things that happen when you get older. One of them is you need reading glasses. He doesn't remember what the other one is. Health and fitness sensors, obviously, body sensors, blood pressure, whatever. Accessing things around us, fine stuff. Low duty cycle Internet of Things, all over the place. I talked about temperature sensing, for example. I've got cars, and my cars have little alarms that if the tire pressure is too low, they start chirping at me I have to go figure out which tire is low, but it's chirping at me that one of the tires is low. So I go around with my pressure sensor and figure out and reinflate it, right? That's been around for a decade at least, right? Connecting anything that's intrinsic data to the internet, right? So this is an eye chart, but I'm handing the team here the PDF and the PowerPoint of this, so you can get in close. But here's security and safety, medical, wellness, sports fitness, life computing, communications, and glamour for those people that care. I have friends who have covered their dresses with lights that flicker constantly. I'm not interested, but hey, there's some people that works, right? Why have a smart house? Anybody thought about this? People have been yapping about smart houses for a while now. One that's certainly taken over is pervasive entertainment, you know, people sitting on the john streaming something, right? Managing electric power consumption has been attracting attention, but I think it's better to put solar panels on my house in the first place. But managing it, you know, turning things on, turning things off, when to charge your electric car and when not, stuff like that. Security, you've all heard of Simply Safe and all the other people who Wi-Fi connect everything to connect to sensors and door this and that. You can manage comfort. And my late wife, always used to say, if we're going to make smart houses, how about make them actually useful? When is it going to vacuum itself? When is it going to clean its own toilets? She was waiting for that, waiting for the latter in vain. Home networks have been heterogeneous. And there's people who build voice controlled things and There's multiple different voice control things, and there's deals been going on since I left the industry. It's common to knit the house together with Wi-Fi, but it's also possible to knit the house together with Bluetooth, especially if you have the longer range and or if you've got mesh networking. And Bluetooth has added mesh networking and longer range in the 7 years since I've been out of the industry. Historically, home automation vendors have been the major users of Zigbee, but Wi-Fi and Bluetooth, I think, are taking over.
That's intellectual property issues, I think.
Right. And they didn't have the structure of Bluetooth or USB where they share your intellectual property if you prove compatibility. So that's, in my opinion, a self-inflicted wound. Let's tie our shoelaces together. Okay. Now, last application. So I'm still at CSR, and I'm working with a bunch of other people who are also standards architects. And one of them, my boss goes off to a Wi-Fi Alliance meeting. And the Wi-Fi people want to be able to do Wi-Fi Direct. Has anybody ever heard of Wi-Fi Direct before? Both of my HP printers do this already, and it's supported by my operating system, which is Windows 10. So Wi-Fi Direct, if you've got the ability, you ever heard of the word exaption? EXAPT? It's a term that comes originally from biology because it describes a lot of things that happen in evolution. If you got something that kind of works, you might use it for something else as well. That's how we got eyes, for example. If they've built a radio for local area wireless local area networking, which is 802.11. And suppose instead of going up to an access point or from where I am out to the internet and then back down again to something that's close, why not go directly? Given all the data and all the airtime that would be taken up, why go up and then go down and buffer it in between, right? So I'd like to go direct. And they were wrestling with this for a while. And the Wi-Fi Direct people had two methods, one of which was they would beacon directly on channels 1, 6, and 11 in the ISM band, hoping the other device is listening in the same bands. Or if you're connected to the same access point, they'd use something called universal plug and play and find other devices in your house and go perhaps discover that if they could also find each other directly, then they would connect directly. And my boss came back and said, it doesn't work. You know, too many problems. You're a Bluetooth guy. What would you do? I said. So we prototyped it, proved it worked, disclosed it to the patent office. They granted the patent in 2015. And to make a long story short, a device can beacon on the 3 discovery, advertising channels. Another device might be listening. They hear each other. They can say, I got these radios. I got these radios. Hey, there's an intersection. Let's use that one. Boom. Right? So this thing here, the operating system supports Wi-Fi Direct to my HP printers. Just works. Same thing is supported in my daughter's MacBook, Mac OS. And it seems to be supported by at least my more modern iPad as well. And so now I can print things to my HP printer from my iPad. It just binds in and it just works. So he said it would be useful. I proposed this method. We tested it. We disclosed it. That's the patent number. If you want to find it, that's what it is. It's in Wi-Fi Direct. And it became, in the Bluetooth SIG, the Transport Discovery Service. So remember back when I talked about this history here, right? This one here. When you've got Transport Discovery Service, you don't need this. It's completely obsolete. In fact, you can not only do Wi-Fi direct, you can do mobile radio direct. You could do 5G direct. If this device talks to another 5G phone and they're blazing fast, they can just talk directly. Don't even bother with the network. Make sense? Right. So that's around, you can find all these things. They're publicly available on Bluetooth.org. Now, I don't know how far we are, but it's 7:15 and there's been traffic that you and I generated, and I mined that for 8 questions and issues that I thought that this group would want to hear about, and maybe you'll think of some more. Fair enough? You got time? What?
Go wild.
What?
Go wild.
Go wild. Okay, you want to know resources and design pointers. You want to know about guides for adding Bluetooth to projects. You want to know about how to get around manufacturers' poor choices. You want to watch who to pay attention to, how to go completely wireless for ham apps, how to go wireless in digital modes. You want to know about one-to-many audio sources, and you want to know how that VS3 works. And you sent me the manual for that, and I read the manual this afternoon. It'll talk to this thing. So, resources. A lot of books. It's much too larger book to talk about. My students joke about the University of YouTube all the time. Some of it's accurate. Web searches, obviously. Nordic Semiconductor and Qualcomm are 2 of the big vendors that my students are interested in. Qualcomm bought Cambridge Silicon Radio, so now they're now one and the same. Find their local field application engineers. Those people are worth their weight in semiconductor. The Bluetooth Special Interest Group itself is right here in Kirkland. Now, the reason I got the job at Cambridge Silicon Radio, so I was a seasoned standards engineer from a long time previously. Oh, wow. I know that book. And this company is in Cambridge, England, 8 time zones away. And they want to have somebody who's competent, but who is 10 miles away from Kirkland. So if CSR has a problem with the Bluetooth SIG, I can be at their front door in half an hour. In fact, I could bicycle from my house in an hour. Right, so they couldn't get away from me anymore. So it was a win for them, and it was really fun working for CSR as long as it lasted. It stopped being my job because Qualcomm got permission from the Chinese antitrust people, they exist, to buy CSR in August of 2015. So 2 months later, I turned 65. They lay me off, and they give me half a year's salary to go in, not sue them for age discrimination. Thought about it, and I said, yeah, okay. And the good part was they bought out my stock options at CSR, and that means I paid off my house. So all I have to deal with now is King County twice a year. Anyway, my question to all of you is, okay, so Toby Nixon used to chair the Bluetooth Special Interest Board of Directors, but Microsoft engineers working on the engineering committees were pretty scarce, even with physical proximity. And my question is, are there any Microsoft engineers that are active in the Bluetooth Special Interest Group technical committees now? Because if you wanted to know who's hot, find out who's been showing up and inventing new stuff. That'll answer a lot of questions. Make sense? You know, because my connections are relatively stale. I mean, I got friends that still work at CSR and, you know, who have retired from Broadcom, et cetera, but you know, I'm not actively participating in. What I am doing is advising a bunch of my students who are using stuff that comes out of the SIG to do interesting things, but different things than ham radio. Make sense? Okay, that's my answer to the first thing. Okay, second, how to add Bluetooth to projects, new or retrofit. First of all, see the above. I brought my latest issue of QST, and it has an article that I flagged. Came in the mail today. Fun in the field, right? Anytone BT01 Bluetooth speaker microphone. It might talk to something that you make or would like to make. Amateur radio companies may build things like this. Obviously, ICOM, whose engineering headquarters is in Kirkland or North Redmond, actually, up on Willows. That's the last time I looked, it was. They don't, you can't walk in the door and get anything fixed, but they have engineers around here. And that's not very far from Bluetooth SIG headquarters. Bluetooth connected peripherals. I brought digital. Does anybody know what this is? It Bluetooth connects, and there's a physical cable that goes into your radio. It uses a Bluetooth to talk to basically the management plane. So I connect this either to a PC or to an iPad to set it up and configure it. But then it talks by wire to your radio. Anybody ever seen these before? Mobile linked? Okay. They're very popular in my club.
What's the brand or? I think it's hard to see what it.
What Bluetooth profile are they tunneling at serial traffic?
I think it's
Oh, yeah. Connor was talking about this.
right. I think it's using classic stuff. The Mobile Link PNC is the thing. He sent me the manual for the VS3 this morning, and I discovered this afternoon by reading the manual for this radio that there's a whole chapter in the advanced manual on how to compare it to the VS3.
If you're looking for tools, if you're trying to do this kind of work and you're hitting the wall, Wireshark has an extension that you can look at both classical and
Okay,
electric.
good.
You just need to get Nordic makes a little dongle.
Mhm.
You
Right.
put it on, it's like $10,
Right.
and you can monitor all the traffic.
I have old versions of those that are obsolete. I should get one of the Nordic ones.
The new one actually supports all the 5 series.
Right. Okay. Good.
But you need to get one of these. Like I said, they're really $10.
Oh, I'm sure. Right. So, okay. So ideas for working around manufacturers' core choices for BT implementations. Now, again, I extracted these from Hopper's email. So I'm just walking through his list. When I get through my list, if I've failed to meet one of your needs or questions, we'll see how far we can get with it. So Bluetooth represents a common work on a shared radio transport. There's a series of profiles and services that use those radios, but any given product, you know, this thing only does 2 things, right? So it's fairly common to find things that do hands-free profile, but hands-free profile mixed with HID for a control like PTT, they're less common. And when I read the 3 manual, I believe that that's what they've done. And it's quite legal for them to do that and test for compatibility, et cetera. They didn't put a PTT button on this thing because it didn't occur to them. So there we are. It's failure of imagination, right? Who to watch? If there are Microsoft engineers who represent Microsoft on the SIG, find them, they'll know. But if they don't exist, then you're a little bit blind. On the other hand, Microsoft has been a paid-up member of the SIG since it started, and Microsoft is entitled to send people to those meetings. And since they're headquartered locally, at least one meeting a year is going to be an easy drive. You could walk there if you wanted to.
My impression of Microsoft is that they're among the last companies to adopt Bluetooth. They fought it with their own little dongles forever. And it seems like they only reluctantly adopted Bluetooth.
I'm sorry. Back in the day, we were a little bit more aggressive about pushing things. Mike Foley, who used to be one of my colleagues in Windows networking, became the second general director of the Bluetooth SIG. He left us and became their general director. So we were active back in the day. And like I say, Toby Nixon was the chairman of the board until February.
The keyboards, the mice, they were never
Really?
Bluetooth. They always had little dongles, and they just.
Well, they might have needed little dongles because a lot of PCs are made without Bluetooth integral in them. So you need a little dongle.
Long after PCs had.
That's sort of the trending now is with the Wi-Fi, Bluetooth, and everything. The reason for it is because they can coordinate the transmission on the same frequency, so they don't get.
Right. Right, because we actually built all those specs in the early 2010s, you know, for coexistence so that one radio didn't squash the other one when they're close. So in my day, which is now 8 years ago, the most active companies were Broadcom, Cambridge Silicon Radio, Qualcomm itself, and Nordic Semiconductor. Who they are now, I don't know, but Nordic is, yes, Nordic is, someone brought Broadcom, Qualcomm brought CSR, but yes.
In the devices themselves, in other words, the small thing.
Right.
Nordic is dominant
Huge.
in the laptops and iPads.
Okay.
Qualcomm is more prevalent.
I'm not surprised because Qualcomm,
They can bundle all their.
you're right, and
together.
Qualcomm does big bundles that go inside
Yeah.
here too. They dominate that. Right. Okay. How to go completely wireless for ham apps? Well, depends on what you're trying to do. Okay. Obviously, it does streaming audio, and I believe that this thing is using streaming audio. Digital data, medium rate, send it as plain data, packaged in some fashion. And you might also deliver digital data at low duty cycle. That would be a good application for Bluetooth Low Energy.
So Scott has actually a related question to that. Is there a standard for push-to-talk implementation? Is there a profile?
Not that I'm aware of. Push to talk.
Is that
And
incorporated within the HID spec?
I would, that's, if I had to do it, that's what I would do.
HID actually is open-ended. There's a part of it where you can do whatever you want.
Right. And it was designed that way.
It was designed that way.
Right. And so people have been making up stuff for years.
So until there's an independent specific spec, that's where you go look for it.
And if
Yes.
I had Wireshark, I would snoop on what a VS3 says to one of these guys, and you'd probably discover what it does.
You may or may not, depending upon the encryption level and what they're doing. In other words, you'll get the up to the word they finally say, you know, they're going through the bonding sequence, and they'll go, okay, now we're gonna turn on.
Yeah, if they turn on.
As soon as they turn on encryption, and unless you're in debug mode. You don't have to.
Right. I remember the last major piece of work I did on the main core spec was to add AES 128 for both transports. Big deal. All that bonding and, handing off this and that.
If I was able to decode that PTT that they use,
Right.
thing,
Mm-hmm.
because of the way it's set up, could I reuse that same thing? Did they turn over that IP?
Well, if you do the same things,
Yeah.
there's an advantage to the other vendors and you doing the same thing, because that means you're building something that's compatible, right? And you'll have to, get it qualified, but that should work. Yes, sir?
One of the things I would say is, yes, okay, this is my HIT experience again, is if you follow HIT, you're going to get it, you get the interoperability. The problem is that the outside the scope of HIT,
Mm-hmm.
how you do your security,
Yes.
what level of security you're doing. And that's where I get you can play whack-a-mole if you're trying to do Windows and Mac and Linux, and iPhone, and
iOS.
interface the situation a little different.
Right.
And you get into it's like, okay, so now I got my Mac working, and then go over and look at my Windows. Said I don't like the way you do the security, and then we go up to the next one. It's, like I said, it's whack-a-mole, it's trying to keep them all. And it's the interpretation of
Right.
of something that was not defined by it.
Right. Now, if you really wanted to make things happen, you would have an engineer, one or more engineers, who participated in the SIG engineering work. And you would come up with a profile variant of HID, let's say, or you'd come up with the amateur radio profile. And the amateur radio profile would reference streaming audio if you wanted to do it by legacy Bluetooth or LE audio, because there now is LE audio, and HID over LE, because it's low duty cycle, for things like PTT and any other controls you want, right? I look at this thing here, and it's got a PTT button, but it's also got up and down buttons and two other buttons that control other things on this radio. So I might come up with variations for those too, as part of the same thing. Now this is 11 or 12-year-old tri-band handheld. So this is too old, it doesn't do Bluetooth. But I'm pretty sure that there are modern handhelds that ICOM makes and other companies might make that would talk to the VS2, which is this little gadget that you were telling me about. VS2 will talk to this guy, but this is a design that's only a year or two old. So I own a pair of these guys. One of the reasons I got a pair of them is so that I can prove compatibility, having one of my radios talk to another one of my radios, and then I can go out and talk to everybody else and know that things work. It plugs into a radio wired. Basically, there are cables that you get that plug into this thing and plug into wherever audio goes in and out, like right here, plug in, audio. This is mic and speak. This is the audio now. So I plug in place of this. I have one of these cables that plugs into MobiLink. So I think IMO, the audio data from SCO might be adequate to support digital modulation schemes like VARA. Anybody know what VARA is? Okay, some of you do, right? Now, VARA is, the modulation and demodulation is being done in software in a driver and then exported to and from the audio paths on an amateur radio, right? So I have a cable that plugs into this, the cables that plug into, well, maybe not, because there are cables that plug in here. So I could use all those and do all sorts of different bands. One-to-many audio sources. Okay, so SCO includes broadcast mode. SCO is now 25 years old. You can establish a PicoNet of up to 8 devices. There's one device which is sort of the master, and there can be up to 8 devices in a PicoNet. And an example of the one device might be a TV set that broadcasts audio. Then you can have a lot of people in a room listening on headsets at the same time. And those other devices might be sets of headsets. It might be a sound bar or several sound bars around a room. Now, an open question that I don't know the answer to is which profiles or services use this. But I would go find the TVs that do this and read their manual, and they may or may not tell you. Or put Wireshark on it, see what they do.
Yeah, I think that was used, wasn't the driving force for that, wasn't it in-home people inside the home
Right.
for distributing the stereo systems around?
Exactly. That's exactly what it's for. Okay. Now, I don't know. I haven't gone back to read the LE audio spec because parts that do LE audio are relatively new. But I wouldn't be surprised if they didn't define a broadcast for LE audio also. Okay, good to know. And I want to know what profiles or services reference it so far, because I have no visibility into that. I've been paying attention to other things. You know, my wife died last year. I was kind of busy. How does ICOM VS3 work? Well, I looked at the manuals, and I suspect it's a custom multifunction device. So it does at least 2 different things. It probably does hand-free profile because they exist, and it does human interface device or the push to talk and any other buttons it needs. And it works with compatible ICOM radio. So I looked up this afternoon, web search. I found the advanced manual for this. The regular manual for this doesn't reference Bluetooth, but the advanced manual on the web does, whole chapter on how to talk to a VS2 or VS3. So they designed it that way. So, questions?
705, I'm trying to get the serial connection to work for COM, for satellite operation. And I cannot get it to, I get it to pair, I can't get it to the connection.
This is a Bluetooth serial connection?
Yeah.
Nice to know.
Well, it did it once for 2 minutes.
is it-
That's about all I've been able to get it to do since. But
Do you know if it's using RF comm or if it's using LE?
I have no idea. If you turn it on, you ask it to pair. Settings in the menu,
Well,
right?
the thing is, it's made a decision to pair, but that doesn't mean
Well,
that
I'm
there's.
not into fast traffic.
What?
It'll come up as a call port.
Okay.
But it won't maintain, like, what is a good way of debugging? That, I don't know if it's on the 705, if the 705 is dropping it, it's dropping the Windows machine, or
If there's a Wireshark application, I'd watch that.
The thing that I won't work on Linux a lot. And Linux has a thing called BT monitor, BT-mon, and it will dump out everything that goes across the.
I want to
ACI.
hear about Wireshark from you.
Everything goes across the ACI interface, which is not, his picture.
Right.
Yeah.
It's the commonality interface. It's the spec, all the hardware vendors. match
Right
that.
here, host control interface.
Yeah.
I could probably tell it.
And-
705.
And there might
There's
be
a-
something like that on Windows. I would believe that somebody. And that gives you a picture. So if you've got Wireshark on one side doing over-the-air traffic and you have monitor, BT monitor on the other side, you can then start matching them up and going like, okay, so I saw this on the air and over here I see that happening and he's coming back. And a lot of times they'll actually dump out messages in and the other that's kind of interesting is if you're on Android uses a Linux kernel, and you can use if you want to go. There's a way of getting in there. You get a really nice dump out of that you can just pick up on Wireshark, and Wireshark will parse it all off. And
You can also install Android emulators on Windows.
yeah, that's true.
But yeah, it'll do it. Which is really nice when it does work. It's totally wireless.
Brian, the kernel debugger that I work with, you could attach to the Bluetooth thing.
You can see the HCI interface.
Yeah. There are Bluetooth extensions and debugger commands, but I can't remember what level of visibility it allows you.
I gotta believe that they would have that, just because that's the interface when you go to a bug fix. You know,
I think
whatever you call it, interoperability festivals.
Cautious or whatever. The other first level thing is to check the event log and make sure it's not power off or whatever. There's sometimes that people are nice enough to put interesting events in the event log. Doesn't happen all the time. If you're a developer, I would encourage you to do that. But you know, make sure you peruse the event log for events around the time where it's going away, just to see.
There might be something interesting you can do on the test it off a VM and then the hypervisor would
Yeah, but that's probably what our depth would do, is to get a kernel debugger attachment, and then you'd set a breakpoint somewhere before or after, and then you can step around. You can kind of look at stuff without the source too. So, but,
Any other questions?
um,
Yes, sir.
when you were talking about the subway application where they used Empire
Yeah.
power from the cloud, did you build a device that would be a mix of battery and sort of extended with Empire power, or whatever the term for that is?
You call vampire?
The power where you grab power out of the air.
Scavenged.
Yeah.
Yeah, I mean, if they turn on the lights, there's enough light hitting these things to keep them lit.
one of the professors over there, at least a couple of years ago, he was doing a lot of work on harvesting.
Mm-hmm.
He was interested in TV broadcasting, picking up TV broadcasting and microphone, using that for power.
You know, people have been doing that with Wi-Fi. You know, if we're flooding the room with Wi-Fi energy, and there's 100% sure that there's a Wi-Fi access point around here somewhere, it's dumping out energy. I've seen research papers about scavenging that, rectifying it, and using it to drive stuff. And these things now, they don't need a lot of power. I mean, if you look at what's been going on with semiconductors, you know, we're now building stuff that's like 5 nanometer. You have to drop the power. If you don't drop the DC voltage on them, you get huge, you know, volts per centimeter. You know, you blow things up. I mean, 5 nanometer, that's like 50 atoms. You know, and as opposed to 5,000 or 5, you know. When I was first learning to design integrated circuits at Atari 25 years ago, we're working on 10 micron. Okay, the thickness of your hair is like 10, you know, 10 to 20 micron. You can see that with your naked eye, right? And this is stuff that's more than 1,000 times smaller in each axis. It's so small that visible light can't resolve it. You know, you have to use very high frequency ultraviolet light to even try to etch these things. Anyway, so that was random. Sorry about that. Well, so I got a speaker bio. Oh, I've got a bug on me. That was an ant. It's still there.
Okay. One of the interesting things about, you know, you're talking about like iTag and those kind of devices. One of the things that they're based on, a lot of them are based off, not all of them, they're based off of broadcasting, but they carry the information in what's called manufactured data.
Mm-hmm.
And that's how you can, they just broadcast out a piece of information.
Mm-hmm.
In my cat has an iPad on,
Mm-hmm.
and it gets picked up by anybody that drives by, and they brought in an iPhone, puts it back into a service to find me or find it or whatever.
I might have to crush this thing. There we are. He's still crawling. It, she, I think it's a she. So anyway,
And the other thing that's kind of interesting about that is that they expanded the number of broadcasting channels. You know, you said three broadcasting.
that's advertising channels. Those are the advertising
The
channels.
advertising
Right.
channels, yeah. Well, but now what they've done is they expanded it because there's so many tags out there. They don't want the broadcast, the tags can't be on the Discovery channels. They want them off on their own. So you can pick whatever one you want to do.
That's a change that I was not aware of, but you're aware. So I
I
want.
don't see a lot of people doing it yet because you have to coordinate it between both sides.
Mm-hmm.
Because I
Right.
don't know which one, where.
Of course. One of the reasons we were successful in persuading AT&T to quit doing proprietary stuff and join the ITU basically back in the 60s and 70s is it's very hard to build stuff that you're the only one that's compatible with it. I used to have a cartoon on my wall in the 90s, a Dilbert one about the first video phone. And Dilbert's sitting there in front of a blank screen because there was nobody to talk to. You have to agree to have communication. So let's see, resources. You can go here to find all the Bluetooth specs. You can go, here's some books that I have in my bookcase.
Your colleague at CSR, Robin Hutton.
Right, Robin
Really,
Hayden.
really good.
Yes, and it's here.
Oh, there it is. We did.
Right, Bluetooth Low Energy, because he, more than anybody else, wrote Bluetooth Low Energy. I was his wingman, like he was writing the main spec and I was writing all the test specs. Here's some others. I wrote a handful of articles for the IEEE Consumer Electronics Society magazine. It's been renamed Consumer Technology Magazine, but that's what it was called at the time. And here's some relevant articles. I could send them to individuals, but you can't post them because IEEE owns the copyrights. Now, Microsoft may or may not have paid for an Explorer subscription, in which case you can go see all of them. You can go find all these, right? Okay. What? One would think. So call sign, right? I taught radio classes. I've worked on these things. I've been teaching electronics. Wikipedia page. You can find me here or here.